Oh, let me just make sure that my voice is being recorded. Perfect. Okay, hi ladies, it's Mr. Sullivan. Today we're beginning our new unit, Unit 3, Linear Functions. Today's lesson is Lesson 3-1, Intro to Linear Functions. Today's learning target is, I can apply the properties of linear functions to determine key information about my function. The definition of a linear function is a function whose graph is a line. It can be identified in equation form and that there will be no exponents in the equation. So one of the things that we just need to know is that if we have a linear function, it's just going to be a line. So whenever I have a graph of a linear function, it will look something along these lines. Ooh, that was funny. It'll look like a straight line like this, or it could even look like this. As long as it's a straight line, it's a linear function. Now, you can identify a linear function from its equation just by seeing that there's no exponent. So for instance, I will not have anything like x squared, x to the third, x to the 1/2. I'll never have those. If I want to look at it from a graph, it's a straight line like we see right here. And then if we see the table of values or a set of points, we have a constant rate of change. So the average rate of a change of a linear function is always the same. It's always the same. And it has a special name of this because of this, and it's a slope. So like for instance, it's constant, and the special name of this is slope. So when we look at slope, what we're really thinking about, the formula is delta y over delta x, or y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are just points. So subtract your y's, subtract your x's, and then divide them. Your y-intercept is where your graph crosses the y-axis. So when I have a y-intercept, it's going to look something like this. I could have my y-intercept right here, could be here, could be here. And the reason why we call it a y-intercept is because it crosses the y-axis. Okay? We can recognize it as an ordered pair because it's when x is equal to 0. So let's write that down. When x is equal to 0. Now, your x-intercepts, your roots, your zeros, or your solutions are where your graph crosses the x-axis. So I'm going to draw that visual. So I'm just going to draw an xy. So it's where it crosses the x-axis. So like these are examples of x-intercepts. I mean, this right here is an example of an x-intercept and a y-intercept. But you get the gist. So it's crossing the x-axis here, 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 and here. So these are examples of x-intercepts, roots, or solutions. And the way we write them are x, comma, 0. So it's basically when y is equal to 0. Okay. There are three forms of a linear equation or a function. It is slope-intercept form. That's when your equation is in y equals mx plus b form, where m is the slope and b is the y-intercept. Point slope form, that's y minus y1 equals m times x minus x1, where m is the slope, and then x1 and y1 are any points on the line. We're not really going to look at point slope form. And then standard form, where ax plus by equals c, where a, b, and c are constants. And they're also not fractions. We'll mainly be looking at 1 and 3 and figuring out how to go back and forth between them. So what we're going to do is we're going to answer the following based off the graphs provided. So remember, if it's a linear function, it's going to look like a straight line. So if I look right here, I can tell this is going to be a linear function because it's a straight line. So this does represent a linear function. Now, B says, if so, what is the slope? So how we figure out the slope by looking at a graph is by doing rise over run. So if I look, I'm going to be going down. So I go down 1, 2, 3, 4. And then I go to the right, 1, 2, 3, 4, 5. So I can say my slope is -4 over 5. Now our y-intercept, that is where we cross the y-axis. So if I look, I cross the y-axis right here, and that occurs at 1, 2, 3. This is a 3. So I can say my y-intercept is equal to 3. I can also write b equals 3, or I can write it as 0, comma 3. Now the roots are where we cross the x-axis. So if I look, I cross the x-axis once, So if I look, 1, 2, 3, it's like 3.5 or so. Or approximately 3.5. These are not going to be accurate. And then if it's linear, write the equation in slope-intercept form. So we know our slope, we know our y-intercept, we can put it together. So we know our equations, y equals mx plus b. So we have y equals, our slope is -4/5. And we have x plus our y-intercept of 3. And that's our final answer. Now if I look here, this is not a linear function because this is a parabola. Many of you know that word from last year. So if I look, this is not a linear function. It's a parabola. Now, we can't do b because it's not linear, so it doesn't have a slope. We can do c though, because it does cross the y-axis. If I look, it crosses the y-axis right here at -3. So I can say my y-intercept is -3, or b equals -3, or I can say 0, -3. Now my roots are where I cross the x-axis. So I cross the x-axis twice, once at -3, and then once at 1. So I have x equals -3, and then x equals 1. You can also write this as -3, 0, or 1, 0. And then since it's not linear, we're not going to write the equation in slope-intercept form. We will figure out how to write the equation eventually, though. Okay, part A says, does this graph represent a linear function? So what we need to do is we need to calculate the change in y and the change in x. So when I go from -1 to 0, I add 1. When I go from 0 to -1, I subtract 1. And when I go from -1 to -4, I subtract 3. I can already tell if my change in y is not constant. It is not linear. So let's just see our x's. I keep on going up by 1. So this is not a linear function because my rate of change is not constant. Now my y-intercept is when x equals 0. So if I look, x equals 0, I get 0. So my y-intercept is just 0. Now my x-intercepts are when y equals 0. So if you look here, when y is 0, I have an x-intercept of 0. So my x-intercept and y-intercept are the exact same. So my x-intercept is 0, 0. And since it's not linear, we're not going to write the equation. A, does this represent a linear function? It should say table of values. To go from 6 to 3, I subtract 3. 3 to 0, I subtract 3. 0 to 2, I add 2. 2 to 4, I add 2. So this is linear because my rate of change is constant. So this does represent a linear function. My slope is simply the change in y or the change in x. If you look, your change in y is -3 and your change in x is 2. So my slope is -3 over 2. My y-intercept is when x equals 0. So if I look at my table of values, when x is 0, my y-intercept is 6. So I can say y equals 6, or I can say 0, 6. My x-intercepts are when y equals 0. So when y equals 0, I get x equals 4. So my x-intercept is 4, 0. And then, since it's linear, we're going to write the slope-intercept form equation. So we know y equals mx plus b. We know our slope is -3 over 2. And our y-intercept is 6. So my equation is -3 over 2x plus 6. And that's our final answer. And that's it for today. If you have any questions, email myself or Ms. Townsend.